So now we are in chapter 4. This is the first part of this lesson. It's 4.1. I'm doing the limits and continuity and convergence. We start the first part in this lesson, even though you're going to have 2 or 3 videos for this lesson. It's about the limits of a function at a number plus the continuity. Guys, when I say the limit, what does it mean, the limit? When I write first, how do we write? We write lim lim of f of x when x tend to 1. Like this we read it. What is the meaning of this writing? It means if I have a function, if I am drawing the function on a graph with x and y, we know that f of x represents y and this is x. So it means when I am approaching, or when x is approaches to 1, y will approach towards which value? It means if x is approaching to 1, when I talk about the limit, it means the accurate number doesn't exist. I cannot stand on it. For example, it's a bomb. So when I talk about a limit, it means that there is a bomb and I'm trying to approach to this bomb. I'm trying to move left and right around this point, but I cannot touch it. So what's gonna happen to y if x is there? So if you see limit of f of an x tend to 1 plus, it means I'm approaching to 1 from the right. If I see 1 minus, it means I'm approaching from the left. Those are some rules that we needed to be able to calculate the limit. Number over infinity gives me 0. Sure, we have the root plus over plus, it's plus over minus, it's minus. Number over 0, it's infinity. 0 over number is 0, and infinity over number is infinity. And if you got infinity over infinity, 0 over 0, plus infinity minus infinity, it's undefined. Be careful, guys. You cannot simplify infinity over infinity. You cannot tell me it's like 1 over 1. No, it's not the same. It's not 1 even. And when I say plus infinity minus infinity, here the operation it's plus. But if I have plus infinity times minus infinity, no, the answer is minus infinity. It's not undefined. Now let's move to the first example to understand a little bit the limit. If I have, for example, to calculate the limit of x squared minus 9 over x minus 3, if I come and replace, I will replace x by 3. So I will have 3 squared, it's 9, 9 minus 9, 0 over 0, undefined. When it's undefined, I need to think about another strategy to be able to calculate the limit. Guys, when I say that I got a 0 here, it means if I replace x by 3, I got a 0. It means that there is the expression x minus 3 in the numerator. And if I got a 0 here, it means that for x equal to 3, it means I have an expression x minus 3 in the denominator. So if I can see those two expressions and simplify it, I will not have anymore the 0 over 0. So what I need to think about, I need to think about factorizing to be able to see the factor x minus 3. The denominator, I cannot do anything in the denominator. If I put parentheses here, that's it. But if I look at the numerator, x squared minus 9, it's an identity. It's a squared minus b squared. So how do we factorize a squared minus b squared? It's a minus b times a plus b. You can easily see from where the 0 over 0 came. This was the problem. This one gives me 0 over 0. So when I simplify x minus 3, x minus 3, now I have the limit of x plus 3 when x tends to 3. Now I can replace and I can have an answer for the limit. So I will have it's 3 plus 3, 6. Now, after doing the calculation of the limit, we need to understand when do we say that a limit exists at a point. The limit L, I will call it L, of a function exists at a real value, C for example, if the limit at the left is equal to the limit at the right. So when I have the limit of a function at the left is equal to the limit of the function at the right, I can say that the limit of this value exists. Let's do an example here about the limit, the existence and the continuity, because when we have existence we have continuity. So what does it mean continuity? Continuity, it means I'm drawing the function and I continue drawing. This continuity you are drawing, there is a gap here and then you continue drawing. So when I want to study the continuity at a point, first of all, the point should belong to the domain of definition. If the point is not in the domain, I cannot talk about the limit. I cannot calculate the limit. So first, the point that I need to calculate the continuity at it should be in the domain, and the limit at of the function at the left is equal to the limit at the right is equal of f of a. What does it mean? Let's say I want to see if I can continue graphing. It's a point. I'm graphing. I'm trying to graph. I have this point A. Okay, if the limit be A plus, if here, let's say it's 1, A minus it's 1, and A plus it's 1. It's little bit, and at A it's 1, I can join the point and there is a continuity. But for example, let's say at A minus it's 1, at 8 plus it's, for example, 2, and at A, let's say it's in between. There is no continuity. I can see there is the discontinuity, and be careful. Here, the distance is very small between the point. I'm trying just to show it to you. So that's why when I'm talking about continuity, it means as I can continue drawing. I'm not removing my pen when I'm drawing the function. So when I talk about continuity, I need first to check that the point where I'm studying the continuity should be in the domain, and I need to do the limit at the left, at the right, and I need to also replace f of a. I need to find y of this point, and the three should be equal. When they are equal, we can talk about continuity at this point. It means when you are drawing, you can draw, and there is no discontinuity on a particular point. Let's do an example. I have the function f of x equal to x plus 1 for x bigger than 1. It means if I have a value greater than 1, I'm going to replace to find. If I say, for example, f of 2, how are we going to, where are we going to calculate f of 2? I will replace it here or here. I will check 2 is where? 2 is bigger than 1, so I will replace it here. So f of 2 gives me 5, for example. If I, for example, I'm asking you to find f of 0, 0 is where? 0 is less than 1, so I will replace it here, so it gives me minus 2. So it's a condition. This one is a condition, and you know very well how to draw this. This is a line, this is another line, but it's not one line. It could be, for example, this is the first line and this is another line, but I want to check that where the two lines meet, there is a continuity or there is a discontinuity. How we will see that? By doing the limit. So if I want to study the continuity of this function at, for example, here they are doing at 2, so I need first to calculate uh, the limit at 2 minus, 2 plus, and I need also to calculate f of 2. So our first limit of x when x tends to 2 minus. 2 minus, I want to check where is 2. Less than 2, it's here. I will replace it here. 2 times 2, 4. 4 minus 2 gives me 2. 2 plus, it's in the first part here. This is 2 plus. So if I replace x by 2, 2 times 2, 4 plus 1, 5. I don't need to continue, guys. They are not equal. What does it mean? It means that the function is not continuous at 2 because it's gonna be at 2 minus it has a value. So if I wanna plot that, this one, if this is the point 2, let's say, okay, at 2 minus it's 2, so it's here, and then we make it like this, we open it like this. At 2 plus, there is it's 5, it's somewhere up here, so there is no continuity. I cannot join this part, so there is a discontinuity on this point here. I'll start a little bit with the limit at infinity and I will finish it in the second video. Now we are talking about the limit at infinity. What does it mean, limit at infinity? This one will help me to find something called vertical and horizontal axis. Infinity is not infinity is not an exact number. It's not a fixed number. So when I need to find the limit of f(x) at a number and it gives me infinity, it means when I'm standing, for example, at 2 and it gives me infinity, it means I'm going up, 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 but I don't have a specific location. So if the limit of a function when x tends to a number gives me infinity, I can deduce that x equals c is a vertical axis. It means it's like a boundary. If you have a garden here, if you have a garden, okay, and here it's your friend's house here, and you're not allowed to cross the boundaries. So you can stand here next to the boundaries of the garden, to the gate, but you cannot cross it. So this one we call it the vertical asymptote. So I cannot I cannot step on it. I cannot jump out above the boundaries. I need to stay here. I need to stay here, or on the left or on the right. That's why we call it a vertical asymptote. So also, and you have also something called the horizontal asymptote. So every time I'm doing the limit at a number and gives me infinity, it means x equal to this number, x equal to a vertical line, it's a vertical asymptote. If I look at the graph here, what is the limit of f(x) and x tend to 2 plus? Let's say here this is the ending of the graph. Okay, those are the ending. 2 plus, it means I need to look at the right. Where are the function going? The function is going down, 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 down. When it's going down vertically, it means I'm going to minus, sorry, it's minus infinity. And if I look at 2 minus, this is 2 minus. Here, the function gonna, when I say vertical asymptote, I want to be, the function gonna be parallel to this line. It will approach to it, but it cannot touch it. So when I say vertical asymptote, it's gonna be almost parallel to it. It will continue like that. And either here it's gonna continue down, 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 but without touching it. So if I say 2 minus here, it's this part here, 2 minus, so I'm going up, up, so it's plus infinity. With more practice, guys, you will see it easily. Now let's move to the limit of a function when x tends to infinity. And if it gives me a number, it means when x is, let's say 2, and I'm going to infinity, I'm going to go to plus infinity like this. So I have now a horizontal direction. And here also I have a horizontal direction. So we have a horizontal, we say horizontal asymptote. If I look at the graph here, and I'm asking what is the limit of f(x) when x tends to plus infinity. X plus infinity, it's here. I'm approaching y equal minus 2. I cannot touch it. And approaching it from up, so it's minus 2 plus. And when x tends to minus infinity, if I'm going to the negative part, I feel that the function, the blue is the function and the green is the asymptote. I just want to let you see it. So I feel that in the end, the function is really approaching to this one. It's approaching, but without touching it. So we call it a horizontal asymptote, or a horizontal direction. It's like the horizon. I'm going like this, I'm approaching to it. If it was going like this, it's not a horizontal asymptote. So when x tends to minus infinity, where the function is approaching, it's approaching to which line? It's approaching y equal minus 2 from down, so it's minus 2 minus. Now let's do this example. Every time I need to find the asymptote, I need to find the domain of the function. So what is my domain here? It's x not equal to minus 1. And then you do the limits at the boundaries. When you do the limits at the boundaries, it will help you to find the asymptote. Guys, I will leave this part to the next video. I'll do this one and the oblique asymptote.